Here's the truth about AI agents. They cannot keep a secret. Every key you paste into an agent's config can end up in a log line, a git commit, or the context window of a model that will happily repeat it to anyone who asks nicely. The fix has a name, a credential vault. In the next 12 minutes or so, I'm going to show you exactly what a credential vault is, how one actually works under the hood, and how Tragentics builds one into the road between your agents so they can use keys they never even see. No hand-waving, the real engineering, the encryption, the injection, the time locks, all of it. Let's get into it. So what is a credential vault? Here's the definition, clean and simple. A credential vault is an encrypted store for secrets, API keys, tokens, endpoints, that lets a system use a credential without ever holding it. That's two jobs in one sentence. Job 1. Lock the secret down at rest, encrypted, in one place. Job 2, and this is the part people miss, inject that secret at the moment of use, so the thing making the call never touches it. For AI agents, that second job is everything. An agent that never holds a key is an agent that can never leak one. And look at the picture. Your agent on the left, the API it calls on the right, and the vault sitting in the middle of the road. That placement is the whole story, and it's where we're headed. Why does this matter so much for agents specifically? Count the places your key lives right now without a vault. It's in a .-n file. It's in a config. It's in the context window because the agent needs it to place the call. It's in your logs the first time somebody debugs a request. And it's one bad commit away from living in your Git history forever. That's 5 copies of a secret you can't take back, and rotating that key breaks all 5 at once. And here's the part that's specific to AI. Whatever an agent holds, it can be talked into revealing. You won't fully stop the model from getting confused, so the winning move is having nothing in reach when it happens. One vault, one encrypted copy, nothing to find, nothing to reveal, because a secret you never hand out is a secret you can actually revoke. Okay, how does a credential vault actually work? Any real one, not just ours. 5 jobs in order. Job 1, store. The secret gets encrypted the moment it arrives, and the plain text never touches disk. Job 2, authenticate. Somebody wants to use the key. Prove who you are first. No identity, no access. Job 3, decrypt. In memory, never into a file. Job 4, inject. The key gets attached to one call. And job 5, vanish. Nothing decrypted survives the request. Notice the split on the timeline. Storage happens once. Jobs 2 through 5 run on every single call. And here's the honest bit. Every serious vault does these 5. The real difference between vaults is where this machinery runs and who does step 4. Hold that question. Because vault gets used for 3 pretty different things, let me sort them honestly. A password manager is a vault for people. It fills your logins into a browser, and a human approves every use. Great tool, wrong species for agents. A secrets manager is a vault for infrastructure you run. You deploy it, wire up the SDK, and your code fetches secrets at runtime. Solid engineering, and plenty of teams run one. But watch the key in the middle panel. Your code fetches the secret, and now your code is holding the secret. In memory, in the app, right next to the model. You moved the leak. You didn't remove it. The third kind is newer, a vault built into the transport itself. The secret is injected in transit by the relay, so the agent never fetches it, never holds it, never sees it. One question sorts all 3. At the moment of use, who is holding the plain text? That third kind is what Tragentics builds. The Credential Vault isn't something you deploy next to your agents. It lives inside the relay your calls already travel through. Here's the shape. Your agent calls out, and the call routes through the Tragentics proxy, which is exactly where the vault sits. The road your call takes and the place your key lives are the same piece of infrastructure. So you store the key once. From then on, every call gets authenticated on the way in, gets the key injected in the middle, and gets recorded on the way out. Metadata only, never payloads. Think about what you'd have to build to get that yourself. A secret service, an injection layer, and an audit pipeline, wired together and maintained forever. Here, there's nothing to deploy and nothing to fetch. You paste the key into the dashboard once, and the road handles the rest. That's why I call it the vault that's also the road. Let's open the box because encrypted at rest gets said a lot. Here's what it means in this vault specifically. Every secret is encrypted with AES-256 GCM before it's stored, and each one gets its own unique 12-byte initialization vector, so no two rows ever encrypt alike, even if the secrets were identical. GCM also adds a 16-byte authentication tag. That's tamper evidence. Modify the ciphertext, and decryption doesn't produce garbage. It refuses. And the key that unlocks all of it? A 256-bit secret that lives in the server environment, not in the database. So a dump of the database is a pile of ciphertext with no key in sight. Two details I love. The endpoint URLs are encrypted too. Where your agent lives is nobody's business. And your agent's own TK token isn't even encrypted. It's hashed. One way. The platform can verify it's you, but nobody, including the platform, can ever read it back. Now the heart of it, injection. Watch what happens to one request. Your agent places its call carrying its own TK badge. That badge is how Tragentics knows who's calling, and it is not the key to the target. At the proxy, two things happen in the same instant. The caller's authorization header gets stripped. The target will never see it. And the target's real key comes out of the vault, gets decrypted in server memory, and gets attached exactly the way you configured it. The right header, the right scheme, even a version header if the API wants one. The call fires, and the decrypted key is gone. It existed for milliseconds in memory for that one request. If you watch the proxy video, you already know this line, and it's still the strongest sentence in the product. Never shown to the caller, never written anywhere, never in any response. You've got three ways to hold a key in this vault, and they're really three levels of caution. First, the static key. Stored once, encrypted, decrypted per call. You control the header name, the scheme, bearer, basic, XAPI key, and any version header. Set it and forget it. Second, OAuth2, just in time. Instead of a long-lived key, you store client credentials, encrypted like anything else in the vault. At call time, the proxy exchanges them for a fresh access token and caches it in memory, then refetches 30 seconds before it expires. Short-lived tokens, none of the plumbing. Third, my favorite, time locks. These control when a key works at all. Lock it to business hours, your days, your hours, your time zone. Or go scheduled only, where the key works for 60 seconds after one of the agent's own schedules fires, and that's it. Watch the dial flip to key blocked. At 3 a.m., a stolen connection is useless, and the refusal spells out exactly why it was blocked. Here's the negative space. The list of things this vault will never do. And honestly, this list is the product. Never shown to the calling agent, never written to disk decrypted, never echoed in any response. Ask the API about your key, and you get a Boolean back. Key is set. True. That's it. That's all anyone ever gets. Never in the audit trail either. Rotations get logged as events. The values stay masked. And my favorite, never pasted where it doesn't belong. Free text fields get scanned for key patterns. Paste something that looks like a secret into a notes field, and the platform refuses to save it. Secrets go in. Only proof they exist comes out. So what does all this buy you on a bad day? Say an agent gets compromised, prompt injected, jailbroken, or just confused. Let me be straight with you. No vault stops that from happening. Prompt injection is an unsolved problem, and anyone who tells you otherwise is selling something. What the vault changes is the blast radius. An attacker's first move is hunting for credentials, and this agent's pockets are empty. Context window, 0 keys. Config, 0 keys. Logs, 0 keys. A confused agent cannot leak a key it never held. And if something smells wrong anyway, look at the right side. What the other side holds is a connection, a permission, not a key. End it, and access dies instantly. No rotation scramble, no cleanup across 5 config files. There was never a copy out there to chase. You won't stop an agent from getting confused, but you can stop it from holding the keys. Quick zoom out, because the vault is one piece of a bigger idea. Tragentics treats zero trust as a dial, not a switch, and you set it per agent. The floor, what every agent stands on with zero setup, is everything I've shown you today. Credentials sealed in the vault, the content blind relay, instant revocation, live rate limits. The 3 key styles are the middle rungs of this exact ladder. A static key hands out a little standing trust. OAuth2 hands out less. Time locks, less again. And the top of the dial is per call identity. Every call signed with a private ED25519 key and verified agent pairs on both ends. Turn it up for the agents that touch critical systems. Leave the floor for everything else. There's a whole video on the proxy side of this story. Link below. I'm not going to read you a spec sheet. This slide is the spec sheet, so pause here anytime you need a figure. 3 anchors, that's all. AES 256 GCM at rest, with a unique 12-byte IV on every secret. Decrypted keys live for exactly 1 request, in memory, and the scheduled-only window is 60 seconds by default. Every figure on this frame is verified against the live production code. The pause button's yours. So, one more time the definition, because this is the sentence to walk away with. A credential vault is an encrypted home for your secrets that lets your agents use keys they never hold. Stored once, injected per call, held by no one. If you want the full picture of where this fits, we wrote the complete guide to AI agent security, the whole category, not just the vault. It's on Tragentics.com, linked below, along with the credential docs. If this cleared things up, hit like and subscribe. Everything on this channel is engineering first. No marketing versions of anything. Go build something. I'll see you in the next one.